So it was really, you hear that we want to be your trusted energy advisor. It's more than just a tagline here, right? They really do want us to try to help our members make these decisions, right? So, and there's only so much that you can gain from reading an article or reading that glossy brochure about something. But once you've installed it and you maintain it and you operate it, you will understand that technology at a totally different level that you wouldn't get without going through those experiences. And we learned a lot of lessons off this.
This is Middle Tennessee Electric's Plugged In podcast. This podcast focuses on the world of electric vehicles. It is for all EV enthusiasts, whether you are an early adopter and have been driving an EV for years, or you're just starting your research, this podcast is for you.
Hello, I'm Brandon Wagner.
And I'm Amy Byers, and welcome to MTE's Plugged In podcast. Today we have with us MTE's Grid Application Supervisor, Avery Ashby, and welcome, Avery. And we're going to be talking with you today about MTE's microgrid technology. So that's kind of a mouthful. So Before we get started, I want you to tell us a little bit about yourself, and a little bit about what you do, and exactly what is microgrid technology.
Yeah, so thanks for having me. So Avery Ashby, Grid Application Supervisor. So when I started here, an electrical engineer by trade, right? So I was doing a lot of the renewable type projects. So, solar fields, even for our members that had residential type solar, we would go out there and kind of do a commissioning test of that. So, and then other things I did was program field devices to make sure that our system coordinated and stuff. So as I stayed here a little longer, I got an opportunity to become Grid Application Supervisor. So right now, my job is to kind of oversee some of the applications that are kind of engineering still focused, but it's so over SCADA. I got a couple of developers there that develops our SCADA system, and then we have other programs, like AMI and then power quality type stuff as well. So.
Okay. Well, what about microgrid technology? What is that?
Yeah.
For those of you, I know I'm the oddball. I'm the non-engineer in the room, and I know y'all. Yeah. But maybe we have non-engineers that aren't listening. So
yeah, absolutely.
Kind of dumb it down for us.
Yeah. So a microgrid is something it's a small scale kind of power grid, right? That can operate independently or in conjunction with a large main power grid, right? So it usually consists of several different power sources that are interconnected. And in that interconnection, it could be PV or a battery system, or if you have wind turbines, or even the conventional style generators like a diesel generator or a combined heat and power, depends on what all sources. It takes all those sources and integrates those back into an advanced control system, usually called a microgrid controller. And that controller is the one that kind of manages all those different sources and tries to balance your system, as far as being able to supply power to your system or just kind of interact with your system.
So Avery, we built one of these. You mentioned you that was a project you got to work on at our Lebanon office. Tell us a little bit about what is involved in that system. What parts were involved? You talked a little bit about the integration, but specifically that system. How's that made up? Yeah,
so usually with a microgrid, when you think about them, the standard way, you're usually thinking about it from a campus style perspective, right? So you see those at some university campuses or military bases or even business parks. And as those systems kind of, as the systems kind of mature, you're seeing other use cases like at emergency response centers that maybe some cities have, even some hospital complexes. So a microgrid, you usually think of multiple buildings and the interconnection between those. I would probably say what we've got in Lebanon is a nanogrid, and I hate to use just another, it's a marketing term, but it's the same components, but scaled down to just maybe one building. And that's what we did at Lebanon. At our Lebanon office, we already had power coming from the grid. We already had a generator there. What we did in this project, we added PV, we added a battery system. We also had to add new switch gear that can control those and control the load. So we have electrically operated breakers. And then of course that microgrid controller that I talked about that centrally manages all those systems.
So when you're saying PV, you're talking about the solar panels we have.
That's right.
Just
out
for
there,
those that
that's right.
may not. Yeah.
So we have about 60 kW worth of solar there at the site. It comes back into the main switchgear as well, and that microgrid controller will watch how that's how much energy that's producing, and look at the load of the building, and then also with the battery system, and it just manages the whole system.
So when I think about what you're describing, I'm comparing that to just having a generator. You said we already had a generator there, so I'm curious, what does this? Is it just for reliability? Like, how is a microgrid different from just having a generator?
Yeah, so I mean, what you're talking about there is for backup power, right? So, and you're right. So before we had the microgrid, basically when the power went down, the ATS there, the automatic throwover switch there, would sense that the grid's off. It would fire up the generator, wait till it come up to speed, and then basically the generator would pick up the building. Now that we've got a battery system with a microgrid there, our battery is our first priority to go over to. And since it's inverter based or power electronics based, it can do this much, much quicker. I mean, we've seen switching over to like a quarter of a second. Now we've backed that off a little bit just to help, make sure things are stable there. But in 1 to 2 seconds, the microgrid would recognize that the grids went down and switch it over to the battery system. And the battery is now picking up the whole building. And it'll run off the battery. And the size of our battery can last about 2.5 hours at full load if the battery's fully charged. And of course, our outages don't typically last that long. So it's also, not only did it monitor when the grid went down, but it's monitoring the health of the grid. Hey, I see that the grid's back and it's been healthy now for a couple minutes. I'm going to switch back over to the grid. And it does that all automatic. So, and the first one that I mentioned, so if a car hits a pole out on the street or something and the power goes off, we do have an open transition, right? We'll see the voltage go down, and we chose to have an open transition so the people in the building still sees that blink, but just for that 1 or 2 seconds, and then we're on battery. But the beauty is when it comes back on the grid's healthy, it sees, all right, it's healthy, and it will sync up and do a closed transition. So if you're in the building, you wouldn't know if I'm still on battery or back on the grid. So
quick follow-up on that. Let's say that the grid's feeding the building. At that point, the solar is charging the battery?
Yeah.
And if the battery's full, what happens to the excess solar?
So, yeah. So the beauty is if there is no solar, I mentioned the 2.5 hours, but if the solar's out there, that also helps extend the battery as well. So in the fact of, hey, we're getting 60 kW into the building just from the solar. Okay. So if the battery was fully charged up, which it typically not because we'll use it on a daily basis, but in your scenario, we can even start curtailing the solar to where, hey, I see that it's really sunny outside, but I need you to start producing less. Or we could sell it back to the grid. Now, at this location, this is before we had, the ability with TVA to supply back on the grid. So our location specifically, we didn't want to export back onto the grid, but a lot of other microgrids allow that.
So you're using, you had mentioned when the power goes out,
yes,
you can use that as backup. But then, so if the power doesn't go out, you're still using that to offset some of your usage throughout the day. Is that what you're saying?
Yeah, and thank you for that. So we mentioned backup power, and that's usually what most people think of as microgrids, is this little island that manages stuff. But if you have something like that, you're going to want to use the additional services that you can bring onto it, right? Because we don't see a lot of outages. That's less than 1%. I want to utilize that system the other 99.9% of the time. And what we use at that building, we'll do it for demand reduction, right? So, residents, we only get charged on energy consumption, but our commercial and industrial people, they'll know that, there's an energy component and there's also the demand component.
And we've had a podcast about that, explaining demand.
So it'll look 24/7 of what the building consumption is, and it'll see, okay, hey, this is what the building typically peaks at. I'm going to try to reduce that peak, and it'll do it, again, through a combination of solar if it's there, but if the solar is not providing enough and we're going to peak, the battery will start providing that extra additional power so we can get our bills lower.
So not to be the devil's advocate, but let's say you're using it to offset. You've been using it whatever amount of time you use during the day, and then there's a power outage.
Yes.
So do you keep some in reserve for that situation, or if the tank is empty because you used it throughout the day, you're just going to be without power? I mean, explain.
Yes. It's a good question. So yeah, it's really configurable, right? And that's where you'll want to work with your vendor to understand what your objectives is that you want out of your microgrid. So for us, we did want to leave a little leftover reserve for that. But we also wanted to reduce our demand as well. So you have those kind of flexibilities with your grid. But to speak specifically on your terms, if we were over on the battery system, and let's say we start at a state of charge of like 50%, so I can run if the sun's out, an hour and a half. Well, the system's smart enough to see that the state of charge is getting really low. Let's say we had an extended outage, and we don't like to talk about tornadoes or ice storms, but unfortunately they happen. So it'll see that the state of charge is going low. It'll fire up the generator, the diesel generator we have there, and then it will also do a closed transition from the battery being the anchor source to the generator being the anchor source. And so the generator will pick up the building and start charging the battery. So for those really, really long extended outages, I can stay on a combination of battery and generator for a long time, right? And I'm still not relying on the diesel or getting more diesel fuel to fill our generator back up. So it's kind of a nice system. And all those are in closed transitions. Again, if you were at the building, you wouldn't even really know it. But right. Being able to stay on battery longer means we're saving diesel, we're helping our carbon emissions and that kind of stuff. So
wow. Well, I think you kind of already answered in your whole explanation this next question, because I can certainly see the benefit of it. But why would MTE want to build this?
Yeah, so there's really two reasons I can come up with. One of them is our senior leadership has been really, they're forward thinking, right? They're looking at what the new technologies are and some of the things that our members might be interested in, right? So we've done other projects like large solar fields, and we've done a large Tesla battery system at Rockville for demand response. Microgrid was kind of that next evolution into it. So it was really, you hear that we want to be your trusted energy advisor. It's more than just a tagline here, right? They really do want us to try to help our members make these decisions, right? So, and there's only so much that you can gain from reading an article or reading that glossy brochure about something. But once you've installed it and you maintain it and you operate it, you understand that technology at a totally different level that you wouldn't get without going through those experiences. And when we learned a lot of lessons off this.
Doing this microgrid helps us educate ourselves so that we can help educate the members. We always try to be the go-to for information for our members.
Right.
But, I'm sure there was some more practical applications of why MTE thought this was a good plan for us. Can you talk about maybe some of those?
Yeah, with us putting a microgrid at that office, it helps the resiliency. Again, as I mentioned, we don't see a lot of outages there, but we've always have generators at our local offices, right? This will help extend that out for longer style outages. So, and again, it also gives us a chance to try to reduce the demand at those and gives us a chance to look at those new technologies.
Okay.
So you mentioned you can only learn so much reading. You got to really do something. I'm just curious. I'm assuming you experienced challenges you didn't foresee, and I know you mentioned there were some other teammates that were really vital in installing this. Could you talk a little bit about what were some of the things that were unforeseen that you had to wrestle with?
Yeah, absolutely. And there was plenty of those, right? One of them was, this is in a retrofit type building, right? So we did get to leverage a little bit as we were upgrading our different local offices. Lebanon was also going through a renovation as well. So we kind of tagged onto that, which would made it a little easier. However, there's still employees in there, there's still operations. So we had to kind of work around those kind of challenges. We couldn't have long-term outages. And of course, there's computer equipments in there that need to run 24/7. And although they say have a UPS on them, I can't take 8-hour outages for that. So working around existing infrastructure is always a challenge, right? And then there's also, supply chain, and that's, everybody's familiar with supply chain issues, especially when you're getting batteries. You order the system and then you're waiting 9 months to a year before the stuff comes in and getting the site prep and stuff. So, but one of the more interesting things that we just really didn't expect until you kind of go through this was the testing aspect. I mentioned that there's different sources. Well, you can think about, all the different scenarios of how does the generator react with the battery when it's doing this? which are your heaviest loads, and we want to make sure those turn on while they're under a battery situation. So there was days upon days, and usually it's nights and weekends, right, to do all this different style testing. But one of the more interesting ones was, of course, we got this battery system in, right? And the battery vendor wanted to make sure it does a full compliance test on it. So it wanted to fully charge this battery as quick as it can and discharge it as quick as it can, right? Well, you don't think about it, but we were setting peak demands at the building during those time frames, and we chose one of those unfortunately, it spanned across 2 different billing cycles, right? So from the perspective of the office, it set a huge demand that it had never set before just due to testing. Now, luckily we're not in a place that has a 12-month ratcheting type demand, but that could affect someone's electricity bill for a long time if you didn't plan ahead, or maybe get a generator in there that can supply the power it needs versus getting it off the grid. So little lessons like that you wouldn't have come up on unless you went through doing it.
So now you're post-install, it's been working for a while, you're probably more in the maintenance mode.
That's right.
Tell me a little bit about what maintenance is like with a microgrid.
Yeah, there's not a whole lot to it, right? You know, it's not a lot of moving parts like it would be for a generator, but we did, we went, the vendor we chose, we also have just an annual agreement with them that they'll come out there and service, make sure that the inverters are working right, run it through its paces. And then with any battery system, there's usually a thermal management system that goes along with it, right? So they're looking over that, making sure everything is in working order. So,
And you mentioned vendor, I think, so Schneider was the vendor we used.
We chose Schneider for this one. They've been a good partner. They're also one of our members. They have one of their local headquarters in our territory. So it was a good partnership that we had. They were also looking to try to find a microgrid that could go into smaller and smaller locations, right? You know, right now microgrids are so engineering service driven, right? I mean, once you start getting into commercial and industrial, there's just too many variables. The residential side of things, I think they've done, you know, Tesla and other people have done a good job of, here's a commercial off-the-shelf solution, right? And as it gets installed. That's not the case when you start dealing with big rooftop units or boilers and chillers and stuff. I mean, a lot of engineering service needs to go into that, but that's what adds to the cost, right? So we really worked with them and partnered with them to try to find ways to make this a little bit more affordable in the future, right? So,
okay.
Well, so now that you've had this, how long have we had it, did we say?
Yeah, about 2 years.
About
now.
2 years,
Yes.
okay. So what are some of the things that you have learned maybe going through the installation of this project or over the last couple of years where we've had it?
Yeah. So I mentioned engineering service, that plays a huge part into that, right? So there's that side to it. But I would also talk about, you know, the documentation. If you were looking at doing a microgrid, you know, this is all custom kind of built, right? You got these different components, but you really need to try to understand what objectives you're trying to reach out of your microgrid, right? And make sure that those are stated up front. Make sure you get good documentation after it's all said and done with. And then another key point is, and we've mentioned a little bit about vendor, you want to make sure you go with a trusted vendor that's done multiple of these microgrid solutions before. Something that's got a good engineering service background to it, because you're going to reach challenges that, you know, maybe it's unique to your plant or your business, and you want somebody that doesn't scare them, or they've seen this before and can work through those.
So we said when we were talking about why did MTE do this, you know, one of the components of that was education, to educate ourselves, so that we can educate our member.
That's right.
So if a member is considering this microgrid at their home or at their office, what suggestions do you have for them?
Well, I would love for them to reach out to us, right? I mean, if they're within our militancy territory, they're a member. We're member owned, right? I mean, that's what we're here for. Please reach out to us. We'd love to share our experiences, love to hear about yours, and we can kind of help, you know, here's what we've learned, and here's some challenges that you may come through. Well, we've mentioned some of them, but I've got many, many more stories about that. So
Avery, this has been so interesting, and I know we're going to want to have you back later, because it sounds like within your job things like this, like the microgrid technology and other new technologies, there's something new all the time.
Yeah, yeah.
So I know this will not be the last time we have
a fun
you.
job.
You
Yeah.
do have a fun
Yes.
job. I mean, every day is different, which
Yes.
is great. So, and I'm sure that our listeners probably have some questions for you. You know, you just had said, you know, we did this so we could educate our members, and you want them to reach out.
Yes,
So,
ma'am.
if anyone has any questions on the microgrid technology, all you need to do is email us at evcarclub@mte.com. We will get that forwarded to Avery.
Yes.
And get everybody connected. So thank you again for joining us
Well, thanks
today.
for having me. Yes.
For more information on MTE's Drive EV programs or the EV Car Club, visit driveev.com or email us at evcarclub@mte.com. Until next time, plug in, power up, and drive safe.